Well, we've heard from a wide variety of experts, both on and off the platform, including those from the classroom. I'm now going to invite one person from each of the collaborating departments of our university who are going to come up and sit down here as I talk. Please. Backing the creation of Cambridge Mathematics to let us know two things. Firstly, what's their one big personal takeaway point from today? And secondly, what does today's launch of the mathematics framework mean to the organisation that they're representing? And as an example, my personal takeaway point comes from our South African delegate. The framework and the attachments are important. But if we don't have a connection to the student, then there won't be any learning or teaching. And perhaps that comes from the romance and enjoyment of maths, I don't know. My generic point to let you know is that today also sees the launch of the Cambridge Mathematics' very own website. To engage with the concepts we've been talking about today and have that long-term conversation, public conversation, obviously you can email Lynn, but it's going to be a lot easier to go to www.cambridgemaths.org, which has all the information you have in print up online and will be increasingly populated with your ideas. So first of all, I'm going to call upon Peter Phillips, Chief Executive of Cambridge University Press, to give us his thoughts. They're going to sit down for this, which I'm hoping is going to keep them tight and very sharp. Peter.
Thanks a lot, Bennett. It's been a really good day, and I just wanted to start by thanking everyone who's been involved in putting this together, and particularly for Lynn for having the courage to put out a first draft of the framework. It's not an easy thing to do when you know there are going to be a lot of conflicting opinions. As a mathematician myself, our conversations today have got real personal significance for me. My own passion for mathematics was kindled not only by great teaching, but also by new approaches to mathematics introduced by the School Mathematics Project that started in the UK in the 60s. They led, for me, to fascination and joy in mathematics in a way which I think drills in arithmetic and geometry wouldn't have done. I'm proud to know now, though I didn't at the time, that Cambridge University Press was heavily involved in the School Mathematics Project. What I think we have now off the conversations today is a new and huge opportunity to help improve mathematical education internationally, catalysed by the combined resources of Cambridge. And the snippets of research which Margaret talked about in the session this morning showed just how important and necessary that is. For me, the key takeout is this. Every single session today has for me underscored the need for deep integration in our thinking across Cambridge. Learning materials, teaching approaches, assessment, all of them need a holistic and joined up approach. I think if we can really join those up, those distinctive strengths of the university, we can really make a new contribution, provided we're also open to working closely with many of you in the room and many other organisations, both in the UK and overseas, and learning from places, as Tim was talking in the last session, like Singapore. I think for the press, we're really proud to be part of this initiative, alongside our colleagues from elsewhere in the university. Maths is a huge part of who we are as an organisation, from Newton's Principia, which we published 3 centuries ago, to publishing in the last century more than a third of all of the people who won the Fields medals. I'm personally committed to making Cambridge Mathematics a success, including, as Dan was talking about this afternoon, innovative use of new technology to complement the existing approaches. I think in every session we've said we want students to master the functional and analytical tools they need for modern life and employment. I believe, though, that we won't achieve that unless we can also, through teaching and resources, excite and engage students by giving them a taste not only of the struggle of learning mathematics, but also of its joy, through encouraging curiosity and playfulness and glimpses of beauty too. Achieving that, alongside the need to balance an evidence-based approach with agility and innovation, are for me critical things for the press to take away. More than 3 decades ago, my mathematics teacher told my class about a French mathematician called Urbain Le Verrier, who, through his modelling, correctly predicted both the existence and the position of the planet Neptune. I still find that amazing. and it inspired me at the time. Today is Le Verrier's birthday, and I hope what we've started here on his birthday can lead to new approaches which I hope will inspire many, many people, both students and teachers around the world.
Next is Charlie Gilderdale, who is, of course, is interim director of Enrich, an early example of collaboration between the Faculty of Education and the Faculty of Mathematics. Charlie.
Thank you, Bennett. Yes, we're very happy to be given the opportunity to collaborate in this way. And as Bennett says, we've got a history of collaborating within the university. So Enrich started over 15 years ago, and initially it was just publishing isolated problems that aimed to enrich students' learning experience with mathematics. But over time, these going from publishing single resources, we've gone to publishing sort of collections of resources, and more recently, rather than just thinking about students, we've been thinking about supporting teachers, about integrating resources into schools, into classrooms. We've had the support from the maths faculty at the university, who we've been working closely with, and we are in constant conversations with the Faculty of Education. In the Faculty of Education, Steve is in the audience here as one of the representatives. We have people like Kenneth Ruthven, who've been working on the Episteme project, Steve, who's interested in problem solving, who's interested in CPD, but in particular in thinking about how research can influence and inform us on good practice. And so it seems to me that Enrich is ideally placed to work together with these organisations, having had a history of doing this already. And it seems to me that the Cambridge framework comes, and Cambridge Maths comes at a really good time for Enrich. We have been progressing towards producing resources that we want to see embedded in the classroom. More and more schools are taking our resources, taking our mapping documents and integrating them into what they do in schools. But a lot of it has been rather haphazard. So having a framework which is research-based, which is well-informed, which tries to link the aims more closely with our aims and assesses the value of these resources in a systematic way, will mean that schools will trust these resources a lot more. So many schools at present use our resources and often think that our resources are there to be used after students have completed the work from textbooks. We'd like to see, and I think this is going to be part of what Cambridge Maths is expecting, to see sort of problem solving, thinking mathematically, to be an integral part of the framework. And so we look forward to contributing to that kind of conversation.
Thank you very much. Next is Nigel Peake from the Faculty of Mathematics. Nigel.
Well, thank you, Bennett. So my personal impression, I've tremendously enjoyed today. I'm a mathematical academic. I'm not an educationalist. So I've learned a huge amount today, and it's tremendously inspiring and reassuring for me to hear about all these wonderful highly professional activities that are going on in this such a vital endeavour. Now, before saying what I think the challenge for my organisation is, perhaps I can just give you 1 minute background about the Cambridge Mathematics faculty. So the faculty is made up of 2 departments, the Department of Applied Mathematics and Theoretical Physics, which I'm a part, and also the Department of Pure Mathematics and Mathematical Statistics. So together we make up the faculty, and in addition to those 2 departments, a key component, of course, is the Millennium Mathematics project, which is, of course, tremendously successful and will be far, far into the future, I'm sure. Now, we aim to do research and to teach to the highest international standards. And just a word about our research. There's a huge breadth of what goes on, and I think this is maybe one of the things we can bring to this project. So we have people doing research in almost every area of pure mathematics, in geometry, in number theory, in logic. We have people working in theoretical physics, most famously Stephen Hawking, but many other colleagues as well, addressing the most fundamental problems about where our universe came from. We have people addressing really key issues about our own planet. For instance, what do we do with all this CO2 that we're churning out? How do volcanoes work? We have experts in statistics. We have experts in big data. One of the things I was mentioning on that video at the beginning was that as a human race, we produce far more data than we've ever produced. But the only way to understand that data, I think, is through mathematics. So it's a very, very exciting, possibly the most exciting time to be doing mathematics. Now, we've already heard that the project is definitely not about getting more students into Cambridge to do mathematics, but my colleague Stephen Cowley said it perfectly when what we want to do is we want to give as many people as possible right across the board a fulfilling experience, because of course this will enhance the discipline tremendously. I was thinking about our own students and how were they inspired to do mathematics at university, and I think there are various things that happen. One is, of course, many students are inspired by the challenge of the subject, the satisfaction of solving difficult problems. A word we don't use often enough, but it has been used a few times today, is enjoyment. Mathematics can be very enjoyable. Mathematics can be a very beautiful subject. And of course, mathematics now has more applications than ever. So one of the messages we're always trying to get out is that it's possible to have a career as a mathematician doing mathematics in a huge range of different fields. You don't have to be an academic to do mathematics. There's a huge range of careers that you can pursue. The engineers are very good at getting this message out, but that's not something we need to work harder at. So one of the things we may be able to contribute is to do with applications. I personally have been involved in something with the Institute of Mathematics and its applications called Mathematics Matters, which has been a series of case studies. And this is a case study about a particular piece of mathematics which started in academia maybe, but then has found an application in the real world. And we go from drug modelling to SGI for movies to the financial industry. And what we're finding, although these case studies were originally intended for politicians and policymakers, they have tremendous play in schools as well. So if that's the sort of resource we can provide, then I'd be very happy. I've been very struck by a number of things that people have said. Malcolm Swan talked about the big ideas of the subject and awareness of the power of mathematics. We spend almost all our time thinking about the power of maths and how the different bits of mathematics are connected together. Maybe not obvious at a school level, but we hope we can explain that more. And Daniel Thomas made an excellent point, I thought, about being able to tell pupils, where does this particular piece of mathematics that I've just learnt, where does it go next? And that's, I think, a really inspirational thing for many students. So I and my colleagues are tremendously happy to be involved in this project. We're looking forward to the next 5 years and wish you tremendous success.
Thank you very much. And finally, Simon Liebus, the Group Chief Executive of Cambridge Assessment. Simon.
Thank you, and thank you, Lynn, and everybody involved in organising what's been a very stimulating day. I was amused Peter talked about how he got into maths because he'd been exposed to the SMP as a child, and I'm a bit older than Peter, and I think I must have been exposed to SMP at a slightly earlier stage in its evolution, because it's one of the things that put me off maths pretty fundamentally. And one of the reasons I've been rather excited by this project and our general engagement with maths over the last few years is actually I think there are some real opportunities now to think fundamentally about how we improve maths education. It's a problem that exists throughout the developed world, how we actually get young people to engage in maths, how we can improve the quality of maths education. There are shortages in most developed economies of competent maths teachers. So there are all sorts of issues associated with the delivery of a high-class maths education. And I think a framework's a very good way of approaching it. I think there's been quite a lot of discussion about, and indeed I've been to a number of sort of maths conferences, because it's been said this has been a long time in the gestation, this project. We've been thinking about it and talking about it and mobilising behind it for 3 or 4 years, and I think it will take at least another 5 years to sort of get through to the next phase, or the phase after that. But in the course of that, I've attended many different maths conferences, and this one's been pretty sort of benign and pretty civilised, because we haven't actually ended up with fisticuffs. There's been a bit of controversy. But I think one of the important things for me is that the framework's not a Trojan horse for disaggregating maths as a discipline. More it's about providing an idiom in which a discussion about the shape and requirements of maths education can take place. And I think that's really important. And actually it's absent from a lot of public discourse about maths education. There's been a lot of talk about politics and how maths education can be influenced by politics, influenced by policymakers. I think it's part of our responsibility as a professional community, as educators, as mathematicians, for those of you who are, to take ownership of the discipline and make sure that we've got an idiom that we command that's not at the disposal of politicians. Also, we're involved a lot in English language education, and that was part of the inspiration behind this, because they're the Common European Framework of Reference for classifying language competence at various different levels is very well established. But I think there's an important parallel here that most of us here are native English speakers. We have English as our first language, but of course the majority of the world do not have English as a first language. But in many countries, English education is looked at in much the same terms as math education. It's a matter of enfranchisement for citizens, and also it's a way that people can have an active it allows them to participate much more actively in economic life. So the real challenge is about English language education, and the framework there has been very successful in terms of classifying various different levels of ability and providing a common idiom in which people can agree about certain levels. You have can-do statements associated with the lowest level and the highest level, and it's pretty immediately apparent on an intuitive basis what that means. And I think what we need to do is move to an environment where we can do the same sort of thing with maths. And I think if we can do that, we can make a real contribution. So it's very exciting to be working with everybody in Cambridge, but it's not just a Cambridge-based activity. The idea is Cambridge can be used as a platform for engaging with the community as a whole. We've had many maths educators here. We've had many mathematicians here. We haven't had many industrialists, actually, and that's one of my takeaway points, that we do need to get some industrial. Because one of the big frustrations we often have is that people come and say, oh, you know, we're the maths undergraduates now, they're absolutely hopeless, they don't know anything. All people coming into work in our particular industry are absolutely useless, they don't know anything. And then you say, well, can you tell us what it is that you'd like us to educate them? What do you want us to focus on? And answer get you none. And I think this is a way of tackling that, and as such represents a really positive way forward in terms of improving maths education.
Thank you very much. Well, thank you very much, everybody. I'm not going to say goodbye, because I'm rather hoping that you're all going to stay part of this community, you're all going to engage very heavily in it, and you're all going to help build a Cambridge Maths that has the power and the common backing of the mathematics community, such that, as Simon says, as some other people have said during the day, that at some point you can go to a government that is wondering what to do next and say, well, we've done all the research, we've got a framework, the framework is not an instruction to you, but you use this to create your curriculum, your CPD, your assessments, to deliver a world-class maths education. So, as I say, I'm not going to say goodbye, but we are going to finish now. And I hope to see you online shortly. Thank you very much.